Hello and welcome to this video lecture on bone, muscle, and nerves, where we will explore both the macro and micro structures of these three main categories within histology. My name is Christopher Demas and I will be guiding you through these topics. Throughout your histology course so far, you've been learning about each of these structures individually, so therefore I wanted to take a moment to step back and appreciate them together. Throughout this lecture I am going to show the similar layered structures of bone, muscle, and nerves. These layers are often separated by connective tissue that has similar naming schemes for these structures. In addition, this lecture should give you a better understanding of how the microstructures and functional units come together to form the macrostructures you are observing in the anatomy lab. We are going to take a closer look at the structure of the femur, a muscle in the leg known as the adductor longus and the sciatic nerve that runs along the posterior of your leg. These structures have been chosen purely for composition and can serve as a model for most muscle, nerves, and long bones within the human body. I will start off by drawing the structure of the long bone in the upper leg, the femur. There are two types of bone that I'd like to point out. Compact bone, which is seen as a dense white rind around the marrow space, and spongy bone, which is more delicate inner structure in the marrow space. Compact bone makes up approximately 80% of the weight of the bone and provides the strength. The spongy bone reduces the weight of the bone and provides a space for hematopoiesis, or blood cell maturation. Now let's focus on the structural unit of compact bone known as an osteon, or Haversian system. As we zoom in and focus on a single osteon, you will notice that there are a number of concentric cylinders that the osteon is organized into. Looking a little closer, notice that at the center of each of these osteons is a canal, known as a Haversian Canal. Within these canals, there are blood vessels and nerves. So I'm going to go ahead and label in the vein, the nerve in the center, and the artery. Notice that embedded in the osteons are a cell type known as osteocytes. The osteocytes are mature osteoblasts that have become embedded in the bone. Before we move on, let us not forget the connective tissue layers associated with bone. First, there is a connective tissue layer lining the medullary cavity and within the Haversian Canal, known as endosteum. Also, there is a layer of connective tissue on the outside of bone, known as periosteum, which forms the outermost perimeter of the bone. Endosteum is actually debated whether or not it's found within the Haversian Canal, so make sure you're familiar that it's located within the medullary canal. Those are the two layers that you should be familiar with for bone. One additional piece of information that I'd like to add is that there are also perpendicular canals running through the compact bone, and this is called Voltzmann canals, which is perpendicular, of course, to the Haversian canals. Now let us move on to muscle, and in particular we are going to focus on skeletal muscle. Just like bone, skeletal muscle is also composed of a number of layers. I'll start by drawing in the main part of the muscle belly. Each whole muscle is held together by a connective tissue layer known as epimysium. Within each skeletal muscle are a number of bundled muscle cells known as fascicles. I've drawn a fascicle here in an exploded view. Notice that each deep red colored cylinder represents one cell within the fascicle. Each fascicle is wrapped in perimysium. Looking within each fascicle are a number of muscle fiber cells. Each cell has its own outer coating known as the endomysium. Within each skeletal muscle cell are multiple nuclei that you can see along the periphery, and I'm going to draw that in purple. This is actually specific to skeletal muscles only, as cardiac muscle and smooth muscle are mononuclear. Each muscle fiber cell contains a number of structural units called myofibrils, which are responsible for the muscle contractions, which I've drawn in an exploded view here. The myofibril is composed of the microfilaments myosin and actin that ultimately participate in organized contractions. The functional unit within the muscle fibril is called a sarcomere. The details of the sarcomere can only be visualized under an electron microscope. The repeating nature of the sarcomere creates a pattern of alternating light and dark bands that we can actually see with a regular light microscope. The darker bands are the A bands, and those are where the thicker myosin filaments are located. The lighter bands are the I bands, and are the areas where no myosin is located. The Z bands or discs delineate the borders of each individual sarcomere, but they are quite thin and can only be seen on electron microscopy. Lastly, let's take a closer look at the nerve and its structure. The larger nerve bundles are often situated between the bones and the muscles. However, it's important to recognize that muscles and nerves must work together, and these systems are ultimately integrated. For the purpose of this video, we will be focusing specifically on the structure of the nerve bundle, like the one we see here. The outermost layer of connective tissue surrounding the large nerve bundles is called the epineurium. Within this structure, in this case, is 4 nerve fascicles, each of which are encompassed by perineurium. Within this perineurium is a vast number of neuron fibers that are surrounded by another connective tissue layer called endoneurium. Within the endoneurium is the myelin-coated axons. This should be a sufficient level of detail for now, as we will be discussing nerves more in a future lecture. Now that we have finished drawing this segment, let's take a moment to put everything together. There are 3 connective tissue encasements within the muscle and nerve that follow the same prefix naming scheme of largest to smallest, epi, peri, and endo. Bone has a peri and endo layer but lacks the epi layer. Make sure you are familiar with the name of the muscle structures and the connective tissue wrappings. For example, that a muscle cell contains a number of myofibrils and nuclei wrapped in the endomysium. A fascicle consists of a bundle of muscle cells surrounded by perimysium, and a muscle belly is made of a collection of fascicles surrounded by epimysium. Also remember that muscle, bone, and nerves all work together and are integrated structures, even though they have been drawn separately in this segment. Thanks so much for watching, and I hope you found this to be helpful.